Good afternoon. Welcome to TXAPA Live. My name is Jim Warren. I'll be your producer today. We're going to go ahead and jump right into it today. We're talking about asphalt binders. We've got Chuck Fuller with TXAPA and Tom Flowers with Ergon with us today. Gentlemen, how are you doing?
All right. So, Tom, you're sitting over there in East Texas and Tyler, Texas, right?
That's correct.
Yeah. Really appreciate you being here to help us go through proper material usage with Tack, PG binders, and emulsion. Again, Tom's with Ergon, and I asked Tom to come on board here to kind of walk through this, mainly because we went through the applications of oils and aggregates earlier, and then we had a great discussion last week with Ted Flanagan and Anand at Materials and Test on the dashboard. So what we're going to hit now is Tom's going to walk us through all the nomenclatures, all the informations on binders. And Tom, this is your rodeo. This is your time to play. And the only reason I'm here is to make sure that we stay on time and in budget. That's the main thing. So Tom, take it away, buddy.
Well, good luck with all that, Chuck. Glad to be with all of y'all this afternoon. And as Chuck said, we're doing a kind of a fundamental series for asphalt and hot mix and all that sort of thing. And so we're going to talk about proper material usage. Give you just a little bit of background on me. I'm a former tech site engineer, consulting engineer, county engineer, and been with Ergon now for about 10 years. So this is an interesting topic because I recall back when I was in college, we didn't do a lot of discussion on asphalt. So you know what, we really weren't well versed in cutbacks, emulsions. Didn't even know what an emulsion was when I got out of engineering school. So we're going to cover some fundamentals and get real basic with you. This will definitely be geared more towards the younger engineers, technicians in the highway industry, and try to get everybody a little bit more well versed. So you can kind of see why there might be a lot of confusion. You know, there's a lot of different asphalt liquids out there, and how to know when to use what can be very confusing. So we're going to crank it up with a discussion of different types of asphalt binders. Then we'll kind of get into a roadway type approach with bottom up. What would you use, you know, above your aggregate base course, then work our way up into tacks and underseals and hot mix binders, and then also talk a little bit about specialty applications. So here we go. Asphalt binders, also known as liquid asphalt. Basically, it's a viscoelastic material, crude asphalt, and in ambient conditions, it's basically a solid, semi-solid. So how do you get asphalt from point A to point B? Well, there's three ways that we're going to talk about today. Asphalt cements, basically you heat them up and you pump them, you truck them wherever you need them to go. You can also use cutback asphalts, which is ACs plus a solvent to liquefy and pump those wherever you need it to go. And there's also asphalt emulsions, and we'll talk about all three of those in a little bit more depth here. Asphalt cements, you can just have plain ACs, you can have polymer modified asphalts, and as well as performance graded. Cutbacks, rapid curing, medium curing. There's also special use and all sorts of different kinds of emulsions. So let's get a little bit more into the asphalt cements. Viscosity graded, The AC obviously stands for asphalt cement. If you recall, viscosity basically means resistance to flow. A high viscosity is kind of like molasses. A low viscosity would be similar to something like water. So your AC10 would be a higher viscosity than an AC 0.6. And the number designation out here, you add a couple of zeros on there and you'll get the midpoint in absolute viscosity. So your midpoint would be 1,000 and your range would be plus or minus 20%. For the polymer modified viscosity grades, you're looking at adding an SBS polymer, a tire rubber polymer, something along that line. And the PG grades, you're talking about your liquid binders that are going to be used in hot mix predominantly. And we'll talk a little bit more about those as we go.
So Tom, I got a quick question for the people. If you go back one slide. So for those individuals that are on the call with us right now, watching this, so when we went through the basics of asphalt earlier, and I'm talking about the basics, we had our performance grade. So in the question box, everybody who was on the other presentation, what is the high number? What is the 58, 64, 70, 76, and 82? What does that number represent? And what does it, performance-wise, what does it represent? And what does the negative number, that's the negative 22, 16, 28, what does that negative number represent? In other words, what are we trying to accomplish with the big number? And what are we trying to accomplish with the little number? And we'll come back to that with Jim in a little bit. So in your question box, type in what we're trying to accomplish with the big number and what we're trying to accomplish with the small number. Okay, Tom, go ahead.
Is there a prize for a correct answer?
I will take all the correct answers and publicly announce the winners. How about that?
Very good. And I've got a slide that'll talk a little bit more about the PGs as we go.
Great.
All right, well, let's get into cutback asphalts. Rapid curing RC250s are used fairly frequently in TXAPA. 800 and 3000 I'm not that familiar with as far as usage goes. Medium curing MC30. We used quite a bit of MC30 for a prime coat back when I was at TXAPA. And you also have some special use cutbacks. The rapid curing will use solvents similar to a naphtha, and the medium curing probably something like a kerosene. And you can also have cutbacks that'll use a diesel. And that whatever it's cut back with, whatever the solvent is, generally designates whether it'll be a rapid or a medium cure. And that'll explain kind of what we just said. So I'm going to keep right on moving.
So when you talk about rapid cure, how fast is rapid versus medium cure? So
yeah,
what's your
that's a good
time frame
question.
and what's the cause of
That's
them?
a good question.
That is a good question. The rapid cure, I'm more familiar with the medium cure, Chuck. When we would shoot an MC30 on an aggregate base, we would typically give that somewhere in the ballpark of 7 days to cure out. You want those solvents out of there before you put another layer on there.
Right.
So a rapid cure, would be quicker than that, I would imagine.
Yeah. Good point. Good point. So go ahead.
All right. Moving on to asphalt emulsions. 3 different types there: anionic, cationic, and specialty. The anionics are the older breed of a bunch. You don't see a lot of anionics nowadays. You will still see some. The cationics are much more prevalent. There are non-polymer modified as well as polymer modified, and a lot of those are SBR polymers like a latex. And then you'll have your rapid set, medium set, and slow set with all of those categories, and they all follow a certain nomenclature. And I think I've got that coming up here in a minute. Ionicity, I borrowed some of these slides from Dr. Epps. They put some great slides together for the seal coat program. And so that was a researcher type terminology there. But the anionics will have a negative charge. The cationics will have a positive charge. So you can see the nomenclature with the cationics here. The rapid sets will be a CRS, C for cationic, and RS obviously. The number designation out from that will tell you whether it's relatively more viscous or less viscous.
Mm-hmm.
It would be less viscous to more viscous. You can see some of them will have a letter out there like the CMS2S. The S would stand for a solvent. And the medium sets typically are more the mixing grades. The rapid sets are more for a seal coat type material.
So why is it important to have, or to even know the difference between a positive charge and a negative charge, Tom?
You know, it used to be a bigger deal back in years past. My apologies. It used to be a bigger deal back in years past. We really don't make a big deal out of it anymore. The cationics generally work with most aggregates. If there's an aggregate that you're concerned about or you haven't used before, get them to your supplier and let your supplier check and make sure that they'll work. It's always a good course of action.
So they're compatible. Yep.
Right. You want them to be compatible, but we generally don't have much problem with it.
Mm-hmm.
The slow sets generally are used for maybe like a fog seal. Could be diluted for a fog seal. You can also use it for a full depth reclamation on the CSS1H. And then there's the cationic polymer modified. You'll see a lot of the CRS2P on chip seals, seal coats. You'll see the cationic high float 2P used on seal coats as well. Then the CMS 1P and 2P, which are generally used for scrub seals, things of that nature. And CSS 1P, something typically used in something like a microsurfacing. So where do you use all this stuff? You've got ACs, you've got cutbacks, you've got emulsions. So what I did was kind of showing a little bit of a road construction type of a slide here with the subgrade at the bottom, flexible base right above it. So if you're building a new roadway, you've got your subgrade, you've met density with that, put your flex base in there, you've met density. Then you want to put a prime coat. Some do, some don't, and there's different ways of doing that. And then you'd look at your hot mix layers and whether or not you're going to do a surface treatment, underseal, tack coat. But let's kind of back up and take that step by step. So if you used a prime coat for an aggregate base, what would the purpose of that be? Typically, in my opinion, it's to protect the base. If you cannot get the asphalt laydown machine to the project very quickly, you want to have that prime coat down there to protect from weather. You don't want to lose your base course after all that work. You also provide adhesion for a wearing course. And practices around the state from district to district vary. Some districts don't use a prime coat. Others use like an MC30 or an RC250, and I've seen a grade 5 rock used on an RC250, and that way you can get traffic on that fairly quickly. I've seen some entities will use a mix-in prime where you can shoot a diluted slow set emulsion in with your last couple of inches of aggregate base and work that in and by the time you got that base set up, you've got your prime coat already mixed in.
And Tom, isn't there also an AEP that we can utilize for a prime coat? That's your asphalt emulsion prime for a prime coat?
There is, and I should have included that in there. It's
well, a lot of the MCs, your cutbacks and your RCs are definitely some really good prime coats to utilize, like you said, to not only protect the base, but also that it helps that base stay within that optimum moisture range. You know, right. it keeps that moisture containment good. And you know, I tell you, we've used quite a bit of RC 250 in Central Texas with a grade 5. And the reason that we do that, again, is just what you said, is that we can turn traffic on it. So these farm to market roads, or these roads that you have to build underneath traffic, an RC 250 with a grade 5 is a pretty good prime coat, you know, to protect the base and still let traffic go on it. So that's a pretty good usage of the RC.
Yep. Good point, Chuck. All right. Well, let's get into the next layer, which after you've got some hot mix down, or say perhaps you're doing an overlay, you've got a lot of special specifications that are used throughout the state. And I pulled up some of these at the letting probably a couple months ago, and I was surprised at the different numbers that you could use. I think the initial one, or no, special specification 3066 is actually a district-wide, but the rest of them are item numbers, specification item numbers that you could use for those particular layers, and we'll get into those here in just a little bit. But you know, just for a regular tack coat, which is what we used to use back in the day, CSS1H or an SS1H, possibly diluted, was something that was typically used. But now we've got all these fancy new things in the TRAIL, or the spray applied underseal membrane, like an EBL. So let's talk about those a little bit more. And what the heck is a TRAIL? This newfangled thing that I don't know if Barbarack or Peterson came up with it years ago. Material producer list when the trackless product started coming out, and you've got several producers around the state that have materials that will work for a trackless material in your projects if tracking resistance is important for your project. These can serve as tack, or they can serve as a seal. And you'll see that here in the list that we're fixing to show here. If you can read this, it's a little bit small, but the chart here is showing the tack, the bonding course, the underseal course, what you might use a tack for, or the other two categories for. Just a plain old tack coat, you know, if your existing surface is in fairly good condition, tack coat might be all you need. If you need a little bit more bonding strength, for instance, you're putting a thin lift on top of what's existing, you might want a little bit more bonding strength. So you might use a bonding course, which is special specification 3084, and underseal course. If you've got an existing layer that has a lot of cracking or distress, I would definitely want to seal that. And the different ways of doing each of those is shown in the materials in the next row. For a tack, go ahead.
Well, with that being said, I know it's kind of hard to see this guidance document. We do have this guidance document on our website, texasasphalt.org. It's been revised a couple of times, so it depends on which one you're looking at. I think you got the most current one, it looks like. But I know that that the guys at Materials and Test have changed it up a little bit with the shot rates to match up with the with the shear test, the bond shearing test that's going on. And just for everybody's knowledge is that the new specification requires that we pull at least one shear strength per project. And Materials and Test and all the districts that we've talked to up to this point really want you to pull more than just one so that we can establish a database, okay? We really need to establish a database on what these materials are doing in terms of bonding to the next course, like Tom said, and whether we're utilizing an underseal or whether we're utilizing that bonded strength or that bonded section 3084, 3085. So yeah, we've got a lot of data. There's a lot of data floating around. I know that Materials and Test has a lot of data. I know that Century and Angel Brothers, Stacy Hilbrick has done a lot of work on it, as well as some other contractors. I know we have a lot of data on it. So if anybody has any questions or any comments or needs additional information, just reach out and we'll try to get you in the right spot at the right place and the right person to talk to.
Good point. Yeah, this chart's handy to have around if you're really not familiar with these types of things. I was going to go through real quick what standard materials would be used for a tack, like a CSS1H or an SS1H. You could also use a PG, or you could actually use a TRAIL material. But for a bonding course, that's like a spray paver or a TRAIL product. And then for an underseal course, I'm a little bit old fashioned. I love a seal coat. I don't think anything seals like a seal coat. You can also use a spray paver and bump your rate up maybe just a little bit. You can also look at the TRAIL products that are meant for seals, and those can get you some pretty good bond strengths. The rates, residual rates, typical application rates, really encourage you to talk to your material producer to see what they would recommend for rates on those, as well as, of course, you need to look and see what's required on the plans and specifications. We'll talk more about bond strengths here in just a second, maybe right about now. As Chuck mentioned, the shear bond test is something that TxDOT came up with, I think, about 2 years ago. And they had Texas Transportation Institute do some study for them. And there were several DOTs. NCAT over in Auburn had a test. The Louisiana research outfit had a test. And they were all a little bit different. So they TTI looked at it and they decided to go with the shear bond strength test. And they're gathering data right now, just like Chuck said, required in special specification 3084 and 3085. And I was talking to Travis Patton just the other day and kind of expecting this to become a requirement maybe in the 2024 specification. Right now, the minimum bond or shear bond strength is 40, but everything's pretty much hitting above that, probably in the 50, 60 range.
Unless you have a problem.
You have a problem.
So, yeah, nothing bad happens until something bad happens.
That's right. All right. Then we get to the hot mix layers, and that's what your PG grades are all about. So hopefully you've all got your answers into Chuck, so you can't look off of this and cheat. But yeah, the Super Pave was what replaced the viscosity grades, the ACs, back in the late 80s, early 90s. With the Sharp program. And so now we're taking a look at the binder in about 3 different phases of aging, as opposed to just one data point. And so you're gonna look to see, and I'll show you a map here in just a second to show you where you might make the decision on which one to choose. But a 6422 is fairly common. And the 64 is degrees Celsius, and it's an average 7-day max pavement temperature. Not an ambient temperature, but a pavement temperature. And the minus 22 is the minimum average pavement temperature. So several different grades and different reasons why you may want to change those. One thing to note that when you're talking about PG grades, you can take the difference between the high number and the low number, and that'll give you the useful temperature interval. And if the UTI exceeds 92, then you're, some type of polymer modification or some type of modification is involved. And as I mentioned before, you can go to the online manuals. TXAPA also has some good information, and you can see that a 6422 would meet most of the requirements, but you can bump that to a 70, 76 based on your requirements. See if your project has just an excessive amount of traffic, maybe 10 million easels, you might want to make a bump, or 30 million easels. There are different reasons to move your numbers. But a lot of that is also addressed in TXAPA literature, as well as the technical advisory that TxDOT has on their Materials and Test Division website. Any other comments on PGs, Chuck?
Not right now. We're going to find out if anybody got the answers right.
All right. Well, a few specialty applications involving liquid asphalt, full depth reclamation, which I'm involved with quite a bit around the state, involves a cationic slow set emulsion, or you can use an engineered emulsion. The specification also allows for a high yield emulsion, which is one of the specialties, as well as going a hot route with a foam FDR using the 64-22. Pre-coating aggregates, several emulsions there, as well as AC 5 and 10 or a PG. If you're talking about coal mixes, the lower grade ACs work well for that, as well as some of the emulsions. And typically you'll have a little bit of solvent with making a cold mix. So there's the chart, and there's typical material used with the prime coat. As Chuck did mention, AEP should be on that list of prime coats. Tack coats, there's just a lot of different materials you could use. When it comes down to it, if you're not well versed in liquid asphalt, word of wisdom would be to something like I did in my earlier years. I had somebody in the asphalt industry on speed dial, and if I wasn't sure what liquid binder, what emulsion to use, I would call Tom O'Leary, and that's probably what's wrong with me today. But anyway, that's a pretty good chart showing the different materials. But like I say, there are other materials you could add to that, and every district's a little bit different. Everybody's experiences are different. And we all, with years of experience, we have different opinions. So, this is a topic that could cover several days.
Yeah.
So just kind of an introductory light treatment, and that's about all I've got, Chuck.
So, Tom, originally, the first couple of slides you had underneath item 300 I think we had over 72 combinations. 72 combinations of whether it's an emulsion or whether it's an AC. And I mean, you're right. There's just a plethora of materials that we can use, to better and to get higher performance, more durable, long-lasting life. And you hit the nail on the head when you said that, I mean, with 72 combinations, who's going to be able to know which goes with what? And if there's one thing I can get across to everybody that's out there right now, is that everybody in the major associate industries, we're talking about Ergon, Wright, Valero, Jebro, Martin. I mean, all these guys really and truly are here to help. And I cannot stress enough. I just had a conference with the Houston Public Works, and I had several design engineers on there, and they said, well, what do we use? And I was like, give me what you, and I will send you the specialist that can help you. And that's what we got to do. We got to reach out to our specialists, like Tom said, and have them on speed dial, and every single one of them is available to help. I can't tell you that our major associate members are so good at being able to help with a product selection type. And again, the reason that there's 72 combinations is that we have to really, as pavement design engineers, and I'm not one, but as a pavement design engineers, you got to know what each one of those do and how they are going to accomplish making your product more durable and longer lasting. I can't stress enough. Again, there's only 3 things in asphalt, guys. 3 things, right? We got rock, we got AC, and as Buddy Williams says, we got air. Okay, so we got 3 things. And one of those 3 things, you got 72 different combinations. So when you start thinking about it, it's just endless of what we can do with our materials. And they can perform, and they will perform if designed correctly. So utilize our specialists, utilize the Tom Flowers and the Tom O'Learys and the Ted Flanagans and all those guys and Matt Bird and all those guys that we have. Again, they're there to help and they can help. So I agree with you 100%, Tom. Have somebody, and if you don't have somebody, call me and I'll get you in touch with somebody that can help out.
One comment I would like to throw out there, Chuck, is if you try a particular product and it doesn't work, find out why it doesn't work. Don't just throw the baby out with the bathwater. Dig into it a little bit, and there's no telling what the problem could be, but it could be a perfectly viable way to do what you're trying to get done. But
good point. Yeah, we had an RC250 fell immediately, and it's because we trapped moisture. You know, the base hadn't completely cured out. And when we put the RC250 on it, all it did was trap moisture in there, and the traffic hit it, and we had massive explosion. And you would think never to use that ever again. But you're right, Tom. We went back and looked, and it was way too high in moisture content, didn't cure out properly, and we RC250 did too quick, trapping that moisture in the base. And you're exactly right. Once we figured it out, second phase went a whole lot better. And again, you're exactly right. Figure out what went wrong, and again, utilize the specialists that are out there to be able to help you. So good point, good question. Anybody else? Anything else on it, Tom? You good?
I'm good.
So
good.
What about Jim? Where do we stand, man?
Well, we got 4 or 5 people that got the answer right. 3 or 4 got it exactly right by maximum 7-day high temp and the low numbers, a low temperature design. Several other people were pretty close. Got quite a number of questions that come in, and we're running out of time today. So what I'm going to do is I'm going to refer those to Chuck, and Chuck will follow up with you. David, you had several questions that we will get back with you on that. Did get a comment from Frank Jaster. I think it's worth repeating. Each TxDOT district's pavement engineer is required to prepare a year standard operating procedure, or SOP, which lists the asphalt cutbacks and emulsions they prefer for use in each application. The SOP typically includes rates pavement design engineers are required to refer to these SOPs. So there's a little bit of direction that may cut it down from 72 to maybe a little bit less than that. So, hey, a big thanks to Tom Flowers today for joining us, and always great to see Chuck on board. with us as well. Chuck will be back next week. We're going to continue our fundamentals program, take a deeper dive into mix types. We don't have 72 mix types, not quite. We do have quite a few of them. So Chuck's going to go through, explain those, and get into some detail on those next week. In the meantime, be safe out there. Glad to have you on board with TXAPA Live. Hope to see you next time. Be safe out there. Take care, and God bless everybody.